Hi, I'm Emeline Joy C. Ramos, and for question number 2, a closed system containing 2 kg of air undergoes an isothermal process from 600 kilopascal and 200 degrees Celsius to 80 kilopascal. So, determine the initial volume of this system, work done, and the heat transfer during the process. So, first, we must know all the given. So, we have the mass, which is 2 kg. We have the initial pressure, which is 600 kilopascal. We have the initial temperature, which is 200 degrees Celsius. We have the final pressure, which is 80 kilopascal. So, of course, we need to convert degrees Celsius into degrees Kelvin. And we all know that in converting degrees Celsius to degrees Kelvin, we're going to add 273.15 to make it in degrees Kelvin. Therefore, 200 degrees Celsius or 200 plus 273.15 is equal to 200 plus 273.15. 473.15 degrees Kelvin. This is the value of the initial temperature. So, of course, we must know on what are the different unknowns. So, we're going to find the work done, the initial volume, and the heat transfer in this process. Before I forget, this is at isothermal process. And we all know that in isothermal process, the temperature is constant. Therefore, our internal energy would become 0. So, to solve for V1. So, V1, our initial volume, is equals to mRT1 over T1. So, this formula came from the gas equation, from the ideal gas equation, which is the P1V1 or the PV is equals to mRT. So, for V1, our mass is 2 kg. And the R of air is 0.287 kilojoule per kilogram degrees Kelvin. This is which in terms of metric, while the temperature is 473.15 degrees Kelvin over the initial pressure, which is 600 kilopascal. So therefore, cancel. We all know that kilopascal is kilonewton per meter squared, and kilojoule is kilonewton meter. Therefore, the kilonewton would be cancelled. So, we have cubic meter. Therefore, V1 is equal to 2 kg times 0.287 times 473.15 over the initial pressure, which is 600. So, the initial volume is 0.4526 cubic meter. We have the one unknown. So, let's find the heat transfer is equals to internal energy plus work. Since it is at isothermal process, so change in internal energy is equal to 0. Therefore, the heat transfer in the process is equals to the work done. So formula is Q is equals to, or we may use this formula, mass times R times T of 1 times ln of initial pressure over final pressure, wherein the mass is 2 kilogram times 0.287 kilojoule per kilogram degrees Kelvin times the initial temperature, which is 473.15 degrees Kelvin, times ln of initial pressure is 600 kilopascal over the final pressure, which is 80 kilopascal. So, cancel, 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 cancel. So, here, kilojoule. Therefore, RQ is equal to 2 kilogram times 0.287 times 473.15 times ln of initial pressure is 600 kilopascal over 80 kilopascal. So our heat transfer is 547.22 kilojoule, wherein Q is equal to work, wherein work also is equal to 547.22 kilojoule. So, yeah. Thank you.